Alright guys, this is pages 2, 3, sorry, we already did 1 to 2. This is 3, 4, 5 off of the first review, so we're just going to keep going here, alright? Alright, in number 12, we have the altitude drawn to the hypotenuse. Remember, that or this type of triangle with a right triangle with a line down it. We want to draw our 3 chopped out right triangles of medium, small, right, the large guy, medium-sized guy, and the small guy, okay? Alright, in the really big triangle, we have this entire side, which is 15, so we can call that the hypotenuse, and we're looking for the length of AB, so we're going to put an X here. That's the short leg on this one. Remember, this triangle is getting cut, so this is the short leg, that's the long leg there, so keep that in mind as you go through. The 12 is the long leg of this triangle, and that's all we have. And then in the small triangle over here, we have a short leg of 3. Right? That's a 3, by the way. And a hypotenuse across from the right angle of X. Alright, remember the hypotenuse in this medium-sized triangle would be this side across from the right angle. So, what do we have? Well, if you look, we have the hypotenuse and short leg. So, we can just make a ratio comparing those two. Alright. And then all I have to do is create my proportion, cross multiply and solve. So I can do 15, the hypotenuse, over the short leg x is going to equal the hypotenuse x over the short leg 3. Cross multiply, 45 is equal to x squared. Take the square root. And we're going to do simplest radical form again. So remember, 45, factor tree breaks down into 9 and 5, and then 3 and 3. And then the numbers on the end of the tree are the prime factors, which go inside the radical. Alright, 3 times 3 is technically 9, so we take our set. The square root of 9 is 3, so we bring one number out front, and we're left with 3. Radical 5 is our simplest radical form. And there's our answer. Okay, number 13 down below. We did this question in class, if you remember. We got the altitude drawn to the hypotenuse again. Alright, we have if CD is equal to 6, and this is the ratio of AD to AB is 1 to 5. So remember that it means AD, that ratio, has a value of 1 compared to AB, which is 5 times as big. So what we want to do is call X our common, or if you want to say scale factor. Alright, it's what we're multiplying both 1 and 5 by to get some bigger numbers where something special happens. Okay, so AD right here is X, and AB, which is actually this entire side, is 5X, which leaves 4X for this piece from D to B here. Okay, so we're going to draw out our 3 chopped out right triangles. Alright, and we're going to label. Really big triangle, all I have is the hypotenuse across from that, which is 5x. In the medium-sized triangle over here, remember we're cutting into a short piece on this hypotenuse and a longer piece from this segment. So the medium-sized guy, the longer leg is 4x, and the shorter leg is 6. And then on the really big triangle, the short piece is x, and then the longer piece is 6. And so if we're looking, we should be able to notice those two pieces are in the same spots. So we can do another like short leg to long leg and do like 6 over 4x is equal to x over 6. We're going to get 4x squared is equal to 36. Now remember, in general, if you want to take the square root, you want to make sure that the squared term is all by itself. So we want to divide out by 4 first to get x squared is equal to 9, and then take the square root. Remember, we're really getting 2 possible answers, but we are not accepting the negative version. And then we got to be careful because it says what's the length of BD, which is this part. So BD would equal 4 times 3, and that's 12. Alright, so just be careful with that. Alright, if you set up a different proportion, if you want like 6 to x 4x to 6, okay, 6 to x 4x to 6. When you cross multiply, you're going to get the exact same thing. So as long as your proportion when you cross multiply is the same, you're good. Okay. 14 to 16 here. Find the ratio of the perimeters and the ratio of the areas of the small figure to the large figure. This is important. It says small to large. So the small one has to go first. Okay. And then the second, this is the large is going second. Or in other words, this is the numerator, this is the denominator. Okay. So small is 5 centimeters. Large is 8. Make sure they're in the same units. Okay. This would be the ratio of the perimeters. It's also the ratio of the sides. And then when we want to go to areas, we need to square that. And so we're going to get an answer of 25 to 64 as our answer here. Okay? In number 15 here, we have the corresponding sides. And I could tell because like these have the two sets of angles equal. And this is going on this side here between the two and the one that's not marked. So these are similar. Right, and we can tell here because all the angles are equal. We also have the side angle side here. Here we have angle, so we can tell they're similar. Okay. So we're going to do small to large. So 6 to 8. Remember, this is the perimeters. M-E-T-E-R, right? Also the sides. It's the same thing. And then we want to go to areas. We have to square that. So 6 over 8 squared is 36 to 48. And that's our ratio of the areas. And then the last one here is the two circles. And something to keep in mind, all circles are similar. And this is actually true for any regular shape, okay? Or the same exact shape, like two regular pentagons, two regular octagons. Those are also going to be similar because their angle measures are all going to be equal. And then the sides are all going to be in the same proportion. So those will always be similar to each other. And they'll be in the same ratio, right? So small to large, we have 5 to 16. All right, and once again, you could have reduced this, right? You could have taken 6 over 8 and written it as 3/4, and then got an answer of 9 over 16. Totally fine. So I'll take either answer. It's okay with me. Here you can't reduce it. So this is the perimeters. And then we square them, get 25 over 256, and that's the areas. Okay, also the ratio of the sides. Alright, that's page 2. Alright, these are some questions involving the use of finding missing sides and areas. So let's take a look at number 17. Two sides of two triangles are in the ratio of 3 to 5. The area of the smaller triangle is 45. So if you want to think about it, right, 3. So the bigger guy is 5. The area here is 45. 45. The area here is, don't know. So the incorrect thing to do, the wrong thing to do, is to do 3 over 5 equals 45 over, I don't know, x. This is incorrect because remember, these are in straight units, these are in units squared. You cannot compare them. What we really need to do the right thing is to square out the ratio of the sides. So 9 over 25 equals 45 over, I don't know. Now we can solve for our missing side over here. Pardon me while I look for my calculator of choice. So 25 here times 45. And this is going to be 9x equals 11,025 divided out by 9, and x is going to equal 125. And that's the area of the larger triangle. Alright, so we got choice C. Number 18. The ratio of the areas, right? Areas of two octagons are 25 to 100 and 100, right? Find the length of the smaller octagon if a side is 17. So once again, we cannot compare. The wrong thing to do here, the wrong thing to do, right, is to do 25 over 100 equals and this is the smaller octagon, right? Find the side of the smaller octagon, the larger octagon. So x is over 17. This is the wrong thing to do. To make it correct, we need to square root, right, the areas to get the sides. If you chose to square this side, you could do that. Once again, you're going to have to solve and then take the square root at the end, so that's another option. If we square root, though, we're going to get 5 over 10, which is also a half, right? You could have reduced this down right away and gotten 4. No, we won't do that, but 1/4, right? And then taking the square root, you got 1/2. But 5 over 10 works, and then this is x over 17. And then cross multiply. So 10x is going to equal 75, divide out by 10, and we get x is equal to 7.5. Sorry, this should be 85, not 75. And then 8.5 is our answer. Okay? What is the ratio of the sides of two similar dodecagons of the ratio of the areas are 81 to 36? So 81 to 36, just the square root of that to get the sides. 81 to 36, yeah. So that's 9 over 6, which reduces down. So just be careful, because if you did type it in your calculator, you would have gotten 3 over 2. And then you have to pick the one of these that's in the relationship to 3 over 2. Alright? This is in 3 over 2. This is not in 3 over 2. So just be careful. 9 and 4 don't have anything in common. Alright? Okay. Alright, number 20. In the diagram of triangle ADE and ABC after a dilation centered at the origin. A is 0, 0, B 4, C is getting all the points. What could be? Could be. So, could be means that, like, if you can reduce them down, which one of these is the same answer? So we're looking for equivalent answers of DE to BC, okay? Now, DE is this length and BC is this length. What we want to keep in mind here is that these two triangles are similar. So triangle ADE is similar to triangle ABC because of how they were made. Because they use a dilation, we know that all the angles are going to be equal and the sides are proportional. So we'll know that they're similar to begin with. That being said, the ratio of any two sides is also the ratio of, like, any two sides I can make is the ratio of all the sides, okay? So the easiest thing to do is to find two lines either going horizontally or vertically. So for example, right here, I have AB, and it's 4 boxes across. So I can just count that side. I have AD here, which is 6 boxes across. So I can make a fraction out of those sides. AC is 6 boxes across here, and then all the way down is 7, 8, 9. And you can see that 6 over 4 is actually equal to, right, 9 over 6. 36 and 36 when we cross multiply, right? So these are both equal to 3 over 2. So we want to be very careful that it says DE to BC. So the big side is first and the small side is second. So these two choices have both 2's and 3's in them, but we want to be careful which one we pick based on the fact that we want to do big to small. Okay? Alright, I changed this question up because the one they gave us was really funky up from the exam, so it kind of made it a little bit friendlier, except in doing so we made a couple small mistakes here in naming the figures. So let's switch this up. Alright, what is the ratio of the areas of, and we'll go with ADE, triangle ADE, to triangle ACB. So once again, the area of triangle ADE is 75, and we want the area of triangle ACB for that one. Alright, that's what this should say. And these are just ignore those. Alright, so this is the point 1, 2, 3, 1, 2, 3, 4, 5. That's 3, 5. This is 1, 5. and this is 4, 5, 6, 6, 5. Okay, so just keep that in mind as you're going along. Those are the coordinates. All right, what just happened? Hopefully we're still recording. This computer just killing me smalls. Well, we'll keep going. We'll see what happens. We know we're on this last question. All right, so what's the scale factor? Same thing. I can't count these lines, they're diagonal. I can count here across, and I can count that line all the way across to E. So this is just 2 for the red, and then 1, 2, 3, 4, 5 for the green. Alright, so we can just do what's the scale factor. It's either 2 over 5 or 5 over 2. Just be careful if they say which one's which, right? Like this to this, or triangle ABC to triangle AED. Just be careful. The ratio of the areas is that squared. So 2 over 5 squared is just going to be 4 over 25. And then we're going to use that 4 over 25 to solve for x over 75 here. So we get 25x is equal to 300. We divide out, and x is going to equal 2. And that's our area. Alright, I'm going to stop the video here. Try to at least. And then we will pick up with the last bit.